So this is my capstone pitch. Topic is from UE cap to KPI, UK EU speed and latency forecast. So here's the project overview. We'll be talking about inspiration, scenario, proposed solution, monetization model, problem stakeholder, empty chair pinpoints, goals, architecture snapshot, guardrails, data flow, trade-offs, cloud control and test table, UI usage plan, risk and mitigations. So what are the inspiration scenario proposed solution? So this project gave an early performance read for a new router or hotspot SKU in the UK EU before we spent weeks doing a field test. So the market actually care about that for this SKU is a region, what are the typical P50, P95 downlink and uplink speed, and what is the latency in real condition like rural, urban, and indoor. So how we're gonna do it? Okay, so UK EU field logs are ingested only in UK VPC, and we aggregate it to non-PI KPI table with K anomaly greater or equal to 50. And then we do a lawful transfer. Export aggregates only to Canada via documented UK GDPR mechanism, and we're modeling it with rig regression on aggregates and UE band combo plus versions carrier catalog to predict P50 and P95 downlink, uplink, and median latency. Okay, the monetization model. So this is designed to be sellable. So we charge on the buyers, the hotspot router companies at 500 for one-time run for one SKU in the UK. And for subscription model, we also have a $200 per month per SKU in the market, and that covers up to 2 runs per month for firmware version update. We can give an extra run for $500 each, and the optional lab auto run at 500 per run. This is to be accountable for the call box, all the services fees, and the cloud, we also cover the cloud cost for storage around 500 ETL compute transfer that sum in total around like $100. So all of these are included in our pricing. Okay, so what is the main important ROI for the company? So we have fewer wasted lab hours and faster go no go on launch, and a cleaner story for marketing and for carrier partner. So we're not just giving them a model, we're giving them a prioritized plan with evidence. Problem and stakeholder. So before launches, leader want to know if we ship this SKU in the UK, are we about to embarrass ourselves with bad throughput or latency? So they actually want to answer by localization times band combo, not just does it support band N78, but what's the likely P50 or P95 downlink, uplink, and retention there? They do not want to wait around, like say, 3 to 6 weeks of field and lab testing to get that. So the hard part is gonna be privacy. And the field logs may contain personal data, so the raw log have to stay in the UK. We have to drop all the identifiers, tail GPS, so nobody's precise path remains, and we have to aggregate it. Only those anomalized aggregate can actually export to Canada, and once in Canada, we can treat them under PIP DA style control, encrypt everything, least privilege IAM, auditability, retention limit, and purpose bounded use. So the following are the primary stakeholder, the device model engineer in Canada who want to see which combo are fine, which combos will blow up, the UK lab and field test team who actually run throughput tests and want to clear a test order, not a 200-row spreadsheet. Product launch marketing in both regions really want to a conservative tell they can message. Data machine learning platform in Canada who maintains cost reproducibility and CI/CD. Security, privacy, legal in UK and CA who care about resident key anonymity and log transfer. Carrier partners who care our claims match real deploy combo. And a quick go through of the empty chairs will be the end user. So the aggregate can possibly leak if a miss applies. We have to enforce schema check and the key anonymity greater or equal to 50. Just small rural communities, sparse rural data can get erased or as other, so we widen tails and time windows so rural still surfaces. And low bandwidth field team and contractors. Uploads are resumable, compressed, and have progress because they're often on awful hotel Wi-Fi. Okay, some of the goals. So we have to test the right thing first. Rank the location times span combo to the top 25 capture most block level issues. We have to ensure privacy and legal by design. We want to ensure that our tail plus priority matrix come out fast and less than 6 hours. We ensure the reproducible runs, that every run we produce the same output, the same priority matrix, and we can close it with a lab loop, so we can auto trigger lab test if needed from the matrix, and we can also detect result and ship machine learning versus lab report. And we want it to be cost efficient for the company. Single skill analysis costs like the cloud costs around like $100 to $200, but the single skill analysis for them costs like around 500 end to end. Well, focus, and then they can later on focus on the most critical combos. And there's also field friendly UX, so we want to design that is resumable, small compressed upload, and concise. Okay, so the architecture snapshot and the apps. In the UK side, there's gonna be auth and upload. The user can sign in via Cognito or SSO. And next will be audit and clean. The Lambda audit check the manifest and schema and tag lineage. Lambda clean drops and hash those privacy fields or anything sensitive, and we never get fine grained location. And we get aggregates with the Lambda that creates a KPSLs with keys. And we enforce k anonymity greater or equal to 50, and it's under 50 samples, the cell gets surprised and merged into others. Then we can build like export manifest dataset version, and for example, catalog version has row count, and only the aggregated KPI rows can actually be allowed to leave the UK to Canada. So on the Canada side, so we have the combo planner. That for each location carrier, we take the band combo and the market actually deploys and intersect them and get the combos that we're about to predict. And then for the predict and prioritize side, we run the ridge per target and get a result on the downlink, uplink, median, RTT, and we get a priority matrix with the unsupported first, and the combos band combo that's kind of below the target or expectation, and we least prioritize those data sparse one. We also provide a CI/CD in lab. We have code pipeline that can auto trigger a lab testing, and the result we put it up to S3, and the same we generate machine learning versus lab report, and we can email or chat both the links or the result if needed. Okay, so next slide. So to keep everything safe, we ran with three main guardrails. First, the watchdog. CloudWatch in both UK and the Canada watches upload, K anonymity passes, export speed, pipeline time, lab completion, and email sent. Alert if the stall greater than 10 minutes or retry loop. We also have logs tied on IAM, SSE, KMS on every bucket table, VPC endpoint. It's also reproducible, so every run will be stamped, so you can rerun and get exact the same priority matrix and report. So for the data flow, first will be sign in and upload in the UK. Second will be audit and cleaning in the UK. Next will be exporting the aggregates from UK to Canada. And then in Canada, we can plan the combos to test, and we can predict. And then with these result, we build a priority matrix. And we also have the option next that we can inject this priority matrix and auto trigger lab runs, and we can have system compare machine learning versus lab report and post them to report or email or chatbot the links as needed. And some of the trade-off, we trade off with privacy versus convenience. And so K anonymity can increase some workload but avoids cross-border PII risk. Simplicity versus expressiveness. So Ridge is simple and explainable, not super fancy. That's fine because we just need priority guidance on where to test first. So automation versus flexibility. Pipeline can auto run lab tests in the same order every time, so a special one-off investigation might need it if require a human tweak. So cost versus step. We skip big analytical tools to save money now, but if deeper slicing is needed, we can definitely expand this project and handle it later with later with some field or lab follow-ups. So cloud controls. So this is accountability layer. So here are the following rules. So only aggregates leave UK or EU. So we have like a tiny export lambda ship only aggregate list in the manifest. So we ensure there's no PI. And we tested with the red bar test aggregates only export. So this will scan manifest and Canadian bucket. So it fails. If any like raw ID, anything beyond aggregates exist. And second is k anomaly greater or equal to 50. So the aggregator will enforce k greater or equal to 50. And the test will be test KGE50. So we recompute group count in UK, fail if anything, KPSL have k less than 50. UK residency for raw. So raw upload land in the UK S3 bucket only. And we use test UK raw residency test to test it. So we try to read the canary object from outside UK. We should expect the access denied. Reproducible runs. So every run stamped is going to be stamped, so we get the same priority matrix as output. So we have a test reproducible run test, red bar test. So we have to replay the same input, fail if the priority matrix differ from the last one with the same version pins. We also have guarded CI/CD to the lab. So code pipeline trigger lab controller. Controller only allow approved band combos in force test order. So we have to ensure that with the test lab payload guard testing, we send the priority matrix is unsupported combo. It must be rejected. Also verify lab result run that link should follow a lot order. Last will be encryption and these privileges. So all buckets have to use SSE KMS. IAM rule are Titan scoped, so we will test this with test encryption and IAM test on the test put run KMS key test. Next will be AI automation. So I can use the AI for designing the system. Okay, I design the system, but AI can only assist me in the design process. So AI is allowed to help on like small things, normalizing band combo name, drafting IAM lambda snippets, summarizing schemas, scaffolding unit tests, and cleaning up wording in the final report. But AI is not allowed to silently change anything that touch privacy, residency, lab behavior, or cost. Those parts are always reviewed against official docs. Here are some problems and safety guards. So we know that AI tries to over-engineer. So I hold a stack to a baseline. So the Cognito S3 Lambda batch on Fargate code pipeline, and it has to justify adding new services if needed. So all AI lies about cost. So I standardly checking AWS pricing calculator and I need to set budget alarms. If a suggestion costs more than around 20% over baseline, I have to roll it back. Also, I have to keep a short Socratic log of what I asked AI and what I changed. So there's a traceability on what automation influenced the design. And last, risk and mitigation. So each risk should have a control, an automated red bar test, and an acceptance metrics. The first risk is a privacy leak across borders. So the mitigation is that we export only shipped aggregates, cross-region read blocks, all exports should be encrypted. As mentioned from before, the test will be the test aggregate only export. The acceptance metric is that the cross-border PII violation should be 0 per run, and 100% of Canada object live under aggregates prefix. We have the risk of weak anonymity. We have to enforce k greater or equal to 50, surprise or bucket tiny groups as other before export. We tested with test KGE50, so k anonymity compliance must be 100%. Exported cells with k less than 50 should be 0. Raw data leaves UK, so raw lands only in the UK S3 input inbox. Access only via UK VPC endpoint. Bucket policy denies non-UK GET object. So we tested with test UK raw residency. So cross-region read should block rate should be 100%. All canary read from outside the UK should have access denied. We also have the risk of non-repeatable risk. So given this, we have to stamp each run, and we have to we have to control the version. And for the test will be test reproducible run. So the reproducibility match rate should be 100%. So given the same input with the same stamps and identical tiles, our priority matrix should be the output. And another risk is what if the lab runs the wrong thing or the wrong order. So the priority matrix should drive code pipeline. Lab controller enforces a lotless and order number, so results should be tagged. And the test will be test lab payload guards. So the allowed combo coverage should be 100%, and the forbidden combo incident should be 0. Order adherence should be 100%. So the order should be exact match. And that's the whole project design. Thank you for listening.